Unit number 9, notes number 4. And today, our learning target by the end, we'll be able to make an equation. We're going back to the equation of a line. Remember, y equals mx plus b. Excellent, Andrew, you're right on it. And we're going to do it with a bunch of points. So this is going to be called a scatter plot, and we're going to draw in a line of best fit that represents the data. So sometimes statistical studies are done when we just collect data using 2 variables instead of 1, and we establish a relationship between those 2 things. Those 2 variables, we call this bi, meaning 2 variable data analysis. So data analysis, definitely something that you possibly could do in the real world. Now, I have split my notes up into a left side and a right side. For you, it's all just one vertical page, but for me, I had to kind of split it up a little bit. So if you see it's a little different, don't be confused or concerned. We're going to start right here with exercise number 1. We're only going to do 2 today, so please sit up straight in that chair, get out of that bed if you're in a bed, get off that couch, and let's get serious about this. A survey was taken of 10 high and 10 low temperatures in Fahrenheit for the month of April. Perfect. We are in the month of April. Let's try to establish a relationship between the day's low temperature and the day's high temperature. Right now, we're just going to do a scatter plot for this 2 variable set, the bi-variable set of data, by plotting the x values that are all going across and all of the y values. So, looking at this graph, we have the low temperature on the x-axis and the high temperature on the y-axis, and we're just going to use both numbers to plot points. Now, again, pay close attention to how it's moving by. We talked about this last class when we were doing our box and whisker plots. We're going from 20 to 30 by 2s. We're going from, looks like 40 to 50. Well, that would be weird. This must be 48, 46, 50, 52, 54, 56, 58, and 60. Also going by 2. So we're going by 2s in both directions. So I need to find 26, 49. So if I'm at 20 here, 22, 24, 26, and then up to 49, which would be a little bit short of 50. So right there in between 48 and 50. Then I want to go to 28 and 50. So over one more line, which is 2, and then up to 50. That one's going to hit exact. Now remember, we're not going to see a straight line. This is a scatter plot, so they're going to be all over the place. 30, this one's a high temperature of 57. You know the weather. It's really hard to predict. We don't always, get exact temperatures that we would expect, right? 32 and 54. So a little bit higher low temperature, but not quite the same high temperature. So right there. Again, I'm just going through these, and luckily the x values are in numerical order. 34 to 60. So over past 30 by 2 lines, 34 all the way up to 60 right there. And then 35 and 38. So 35 is in between 34 and 36, and it's a little bit shorter of 60 by 1. So again, right there. 38 and 66. 38 here. 66 right here. That was a very hot day in April, 66 degrees. 41 and 63. So 41 and 63 is going to be right in the middle of that box. Yes, I got that one right. It's hard to see with this board. And then 45. So 2, 4, 5, and 72. Don't we all wish it would be 72 degrees right now? There we have it. Okay. So we have got our scatter plot. All we did is plot points according to the temperature readings, according to the low temperature and the high temperature of the day. And as you can see, we can kind of adjust that, we can kind of expect the lower the low temperature, then the high temperature didn't get that warm. But as the low temperature increased, so didn't the high temperature. And that's just, the way that the Earth cools, right? Now we want to draw a line of best fit through this data set. Good news is I have the ability to draw a line, so I'm going to do that for you. Try to take a straight edge or just use a steady hand and draw a line that goes through the center of the points. It doesn't connect the points, but it goes through the center of them all. So there should be an even number of points above and below. I can see that my line has 3 above and 5 below, but for the most part it splits the data pretty well, and everyone's might be a little bit different. Next up, we're asked to calculate the slope of a line. Remember that the slope formula, this may have been a long time ago, but we still need to remember it, is simply y2 minus y1 over x2 minus x1. So that formula that we worked on a little while ago. And so for that formula to work, we need 2 points. And the 2 points we want to get from the line. So I'm going to try to find 2 dead accurate points, and I should use a different color so we don't confuse them with the scatter plot. So there's one, and I can use this one right here. That one's pretty accurate. Okay, so let's come up with the points. This is at 22, so it's 2 to the right of 20, and then it's up 1 from 46, so 47. So there's that point there, and then this one is at 38 and 62. Okay, so there are the 2 points, the 4 numbers that we need to calculate the slope. Now we want to label those just to make sure we know what we're talking about. Remember, they always come as a pair, x and y. Which one's the first? Which one's the second? Well, if you read the line from left to right, this is the first point, this is the second point. So we can now use those 4 numbers to calculate the slope. And that's going to be 62 minus 22, and then 38 minus, geez. My apologies, guys. 62 minus 47, I was looking at the wrong number. 38 minus 22. 62 minus 47 is 15, and 38 minus 22 is 16. So this is 15 over 16. And if we were to divide that, fifteen divided by 16, we'd get a slope of 0.9375. So a little less than 1, right? So our slope, our m value is m equals 0.93, a little less than 1. Now we want to determine the linear equation for our line of best fit. Well, so we know that the equation of a line is y equals mx plus b. And in order to find out the y-intercept, which I can't get because my line of best fit ended right here, I'd have to substitute numbers in for y, m, and x. Well, I just found out what m is. It's 0.93. What about y and x? Well, I actually got 2 of those points, right? I could use either this one here or this one here. I like to use smaller numbers rather than large numbers. So let's go ahead with the first point, which had a y value of 47 and an x value of 22 plus b. So I've been able to fill in 3 of the 4 numbers. Now I can use that to solve for the one I don't know, which is b. So 93 hundredths times 22 is simply 20.46. Don't be concerned with decimals. That's what our calculator's for. And we still have 47 over here. We're solving an equation, so we're going to subtract 2046 on both sides. And that is going to give us 47 minus 2046. A y-intercept of about 26.45. Okay, so b equals 26.45 right from the calculator. Now we can put everything together. the equation of this line based on the scatter plot, based on the things that I found, y equals a slope of 93/100 followed by x plus a y-intercept that's about at 2645. So if it continued to move in that direction, that's where it would hit the y-axis. So clearly, we were using, remember that the low temperature is on the x-axis. So if this is a low temperature, this is an x value, and we can use our brand spanking new equation to find out the high temperature. So y equals 0.93 times the low temperature of 42 plus the starting value of 2645. So I'm not even going to think about using anything other than my calculator to help me find that out. So 0.93 times, and we said that that is 42 degrees, 42, and then we're going to add the y-intercept that we just found of 26.45. Press enter, voila. A high temperature that day would be about 65, 66 degrees based on our line of best fit. So the y equals the high temperature would be 65.6 degrees when we had a low temperature of 42 based on our line of best fit. Now, would you characterize this relationship between high and low temperature as positive or negative? Well, this is a situation of what's happening on the graph. What type of slope does my line have? My line has positive slope, which means it's affecting these the same way. As one increases, the other increases. So we would say that this is a positive. So like we said, this is a positive correlation because as one increases, so does the other. In order to complete the second problem in the notes, please watch the other video that will be posted.